When I ask students to define what it means for a function to be continuous, I usually hear things such as there are no breaks in the graph, there are no asymptotes, I never lift my pencil when I'm sketching the curve of the graph. And although those things describe the graphs of continuous functions, we need a definition, or it doesn't formally define what it means for a function to be continuous. And to start with, we're going to talk about continuity at a particular number, or for a particular value of a. So let's formally write the definition of continuity. All right, I'm going to write it here. So a function is continuous, or a function f is continuous at a number a if the limit as x approaches a of f of x equals f of a. Alright, that's the definition, straight and simple, of continuity of a function f at a number a. The limit as x goes to a of f of x equals f of a. Now, what this says right here is actually three things. The first thing it says is that f of a is in fact defined. So I won't have a break in the graph at a. Well, that doesn't say that right there actually. It says that f of a is defined. Okay, 2, it says that this limit x approaches a of f of x actually exists. So not only is it defined, but it exists. Or not only is f of a defined, the limit of f at a exists. And lastly, it says that that limit that we know exists equals what the function is at a. Okay, it says all three of those things. So let's first look at this, what this might look like graphically. So I'm going to sketch, if I asked you all to sketch a continuous function, you would get various things, but you would have no breaks in the graph, you would have no asymptotes, you would never lift your pencil off the paper until, well, you were done sketching. So let's see, if I pick this value right here to be a, then let's see if all of my conditions are met. Is f of a defined? Yes, it is. Right? So when x equals a, f of a is defined. All right? Does the limit as x approaches a of f of x exist? Yes, as I approach a from left and right, I see that my function from both left and right approaches the same value. So it does exist. And not only does it exist, but it actually equals the value of my function at a. Okay? So what you all think of graphically as continuity actually does make sense with our definition, or is in line with our definition. One of the best ways to understand a definition is to see cases where the definition does not hold. So let's look to see if one of these conditions is not met, how that affects what the graph of our function might look like. Okay? So let's violate condition 1. F of a is defined. So let's assume at a it's not even defined. So I'm going to have a hole in the graph there. Maybe this is the graph of f. Alright, so here f of a is not defined. Alright, and as you see, there is a break in the graph. There's the hole in the graph. And so as you would answer, if I gave you this graph, this function is not continuous at a, we can also rectify it with our definition. F of a is not defined. Okay? Well, what if f of a is defined, but that the second condition is not met? The limit doesn't exist. So, for example, there's going to be a again. So maybe my function is defined there, but it does something like this. Okay, so here f of a is defined, but the limit as x approaches a of f of x does not exist. And we see it doesn't exist because the left-hand limit does not match the right-hand limit. Okay? Well, let's see a case where the first two conditions are met, but the third one is not. So we want f of a to be defined. So let's say it's defined there. Maybe I have a hole here, and I extend it to the right this way. So here, f of a is defined. What about the limit? The limit as x approaches f of x does exist, right? Because as I approach a from the left and the right, my function approaches the same value, whatever it may be. So this limit exists. However, L does not equal f of a. This limit does not equal f of a. So in this case, my function is not continuous at a, even though f of a is defined, and that this limit exists. But because this limit does not equal what my function is at a, it is not continuous at a. And that is the definition of continuity. In the next video, we will look at some more examples.